Hello there, and welcome back to the Science Sleepy Minds. You lie still, not quite sure if you're falling asleep or slipping between timelines. The air is warm, but there's a faint electric hum in your ears, something primal like thunder rumbling through the bones of the planet. You blink slowly. No, you're not dreaming. Not yet. You're just here with me, drifting through that strange little corner of bedtime where science and storytelling melt together like warm candle wax. Tonight, the comfort of your blanket won't save you from cosmic indifference, solar tantrums, and one very confused Soviet officer. You probably won't survive this, but don't worry, you already didn't. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're listening from and what time it is for you. I want to know who's time traveling with me tonight. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge across an endless stretch of scorched, cracked stone. No trees, no birds, not even insects. The sky above is thick and colorless, a grim dome painted in smoke. You aren't in the future. You've landed in the deep past, 66 million years ago to be exact. And something's coming, something big. This is the before. Before mammals took over, before birds were birds, before humans ever daydreamed about global catastrophe. You're sharing the Earth with dinosaurs right now, and not just the famous ones. Sure, there's a T-Rex stomping around somewhere, but you're also standing in a jungle alive with feathery dromaeosaurs and strange duck-billed herds clicking to each other in dawn's quiet. They're not prepared. You are, kind of. Up above, just skimming the edge of the stratosphere, a 6-mile-wide chunk of space rock is hurtling toward Earth at 45,000 miles per hour. That's roughly 60 times the speed of a commercial jet. You might say it's overkill. Historians, well, geologists, really, still argue whether this was a one-hit extinction or the final knockout punch in a longer, more complex planetary trauma. Some say volcanic activity in the Deccan Traps had already softened Earth's biosphere like overripe fruit. But the asteroid didn't care. It didn't pause for context. You see it too late, of course. There's no dramatic Hollywood-style countdown, just a brightening in the heavens, a sound like the sky tearing, and then silence. This is where we almost ended, except we hadn't quite begun. When the asteroid hit what is now the Yucatan Peninsula, the energy released was roughly 100 teratons of TNT. That's a number so stupidly large it doesn't mean much, so let's try this. It's more than 1 billion times the power of the Hiroshima bomb. Not 1,000, not 1 million, 1 billion. You feel the ground shudder beneath your feet even though you're standing thousands of miles away. The impact instantly vaporized rock, sea, air, and life. It carved a crater nearly 90 miles wide and 12 miles deep. For reference, that's deep enough to bury Mount Everest twice and still have room for a subterranean Starbucks. Heat radiated outward, incinerating forests and creatures in a radius spanning entire continents. The air temperature soared to that of a pizza oven, even halfway around the world. You turn your head and see shadows of animals burned into rock, Pompeii style, caught in the final second of surprise. Then comes the rain, not water but molten glass droplets called tektites, flung halfway around the globe and falling like glittery hail from hell. You try to shield yourself, but this isn't weather. It's artillery from space. The oceans react next. Megatsunamis ripple across entire hemispheres, wiping coastlines off the map. You float momentarily above the chaos, because science lets us do that here, and watch walls of water crashing over what will someday be North America's southeast coast. The Atlantic doesn't exist yet, not quite, but it's definitely misbehaving. You probably think the worst is over. Nope. What follows is the real killer: darkness. Dust, sulfur, and vaporized rock fill the stratosphere, wrapping the planet in a thermal blanket that blocks sunlight for months, maybe years. Photosynthesis stops, plants die, herbivores starve, carnivores follow. Even ocean plankton, the tiny breathing heart of Earth's ecosystem, collapses. The world chokes on its own shadow. But not everything dies, not quite. In the corners of the world, in burrows and under ice and deep beneath the sea, survivors cling on. Tiny mammals no bigger than rats chew on seeds and hide from the cold. Crocodiles float in muddy waters like patient tanks. Even some birds, true descendants of the dinosaurs, endure. That's your genetic lineage right there. Not the tyrant lizards, not the giant sea reptiles, but the scuttling fuzzballs huddled in the dark. You owe your existence to their stubbornness. Here's the weird bit. Despite being the world's most famous extinction, the Chicxulub impact isn't the only time Earth has flirted with total collapse. It's just the best publicist. There were 4 other brushes with planetary doom that were arguably just as dire, just as final looking. And the scary thing is, at least 2 of them happened while humans were around to notice. You lie back now, mentally scorched but safe, listening to the low rumble of Earth processing trauma. There's a cheeky debate still simmering among paleontologists. Was this really an extinction event or just a very intense reset button? Some even argue that without it, mammals, and thus humans, might never have gotten their shot. That's a bit like calling the Titanic an excellent swimming lesson. Here's a fun fringe idea to fall asleep with. A few theorists believe multiple impacts may have struck Earth around the same time, like a shotgun blast rather than a sniper bullet. We only found the big crater, but what if it had company? Sleep tight with that one. Anyway, you survived, somehow, but you're a little radioactive, a little soot-covered, and very, very tired. The dinosaurs didn't make it. You barely did. And guess what? The next ending is only 74,000 years away. You squint upward, barely registering the sky's glow before it unzips itself like a faulty curtain. There's no warning siren, no slow-motion countdown with dramatic orchestral tension. Just boom, everything tilts. You're not sure if it's the planet shifting or your sense of scale collapsing in real time. You're falling backward through a blinding wall of atmosphere, and then impact. The asteroid doesn't just hit Earth. It slams into it like a cosmic punch thrown across eons. The Chicxulub impactor, our not-so-friendly 6-mile-wide visitor, strikes the Yucatan Peninsula with such violence that it drills straight into the crust, liquefying rock on contact. You don't get to watch the crater form. It happens too fast. 1 second it's coastline, the next, it's a planetary wound. You hover above it now, disembodied and untouchable, watching as the Earth responds like a living thing. Mountains ripple outward in slow-motion tsunamis of rock. Superheated air whooshes past, thick with debris and the remains of the last pleasant day Earth ever had. Even the clouds seem afraid. The dinosaurs below don't understand. How could they? A few glance upward, more annoyed than anything else. Then the flash blinds them, and everything else. The global aftershock begins immediately. You're on the other side of the world now, in what will one day become India, watching the sun rise sideways. It's not the real sun, of course. It's the fireball bouncing light across the sky like a disco of doom. The temperature spikes. Trees combust spontaneously. Birds drop mid-flight. You flinch out of habit, but the flames pass through you like a dream. And yet, even now, there's confusion. Historians still argue whether the impact was truly the sole extinction driver. Some point to the Deccan Traps, massive volcanic eruptions that were already underway in western India at the time. They'd been spewing lava and climate-warping gases for thousands of years before the asteroid crash-landed. Maybe Earth was already gasping, and this space rock just finished the job. But no matter how you slice the scientific pie, the Chicxulub blast was a showstopper. And not just because of the impact itself. The real drama unfolded afterward, an opera of destruction conducted by physics and chemistry. Within hours, firestorms ignited across the globe. Think of it like Earth getting peppered with flaming meteorites, not from space, but from the atmosphere itself. You watch charred forests fall one by one. It's oddly mesmerizing, like dominoes made of kindling. The soot rises, joins the growing shroud in the sky, and the planet begins to dim. Photosynthesis stops within days. Crops, prehistoric ferns and cycad relatives wilt in the dark. Herbivores grow desperate. Carnivores follow them down the spiral. It's not a sprint toward death. It's a slow descent, a planetary suffocation. And here's the kicker: oceans don't escape either. You now find yourself drifting beneath the waves, where life had once thrived in coral jungles and endless schools of fish. But the impact turned entire swaths of the ocean acidic. All that sulfur and CO2 released into the air eventually washed into the sea, changing its chemistry like a poison slow dissolving in a bowl of soup. Marine plankton, the base of nearly every aquatic food chain, start disappearing like lights going out in a stadium. It's a death you don't see coming until it's already happened. This is what an extinction looks like when it's efficient. By the end, 3 out of every 4 species on Earth have vanished. Dinosaurs, gone. Marine reptiles, toast. Pterosaurs, nope. Ammonites, extinct. The only survivors are small, tough, lucky, or buried deep enough not to notice the apocalypse happening above. You float into a tiny burrow now. It's cramped and damp, but there's warmth. A rodent-like mammal scurries past your face, pausing just long enough to scratch its belly. You lock eyes with it and realize this is your ancestor, not metaphorically, literally. This panicked, twitchy furball is carrying the spark that will one day lead to you scrolling TikTok in your bed at 2 a.m. There's a strange beauty in that. One world ends, another begins, all in the space of 1 million heartbeats. Here's your weird tidbit to chew on. Scientists have found tiny glass spheres, called microtectites, embedded in ancient amber, actual droplets of impact-shattered earth that fell into tree sap before the sap hardened into time capsule resin. Imagine holding a drop of molten apocalypse, preserved like a prehistoric snow globe. And while we're on the edge of sleep and imagination, let's poke one last fringe theory. Some researchers believe the asteroid may have hit Earth at the worst possible angle, around 60 degrees, which maximized destruction. Kind of like throwing a rock into a pond just right to splash everything. If it had come in flatter or steeper, the damage might have been less epic. Might have. Now the fire fades. The sky, once a canvas of swirling orange and black, begins to settle into a sickly twilight. Months pass, then years. The air cools, but not in a good way. More like nuclear winter meets Victorian fog. You lie on a hillside that used to be rainforest, staring at ferns pushing through ash. They're the first to come back. Always are. And then one day, there's a chirp. Not just any sound, it's the warble of a bird. Small, shrill, defiant. You follow it through the brush until you spot its awkward frame. Feathers still half reptilian, eyes sharp, brain far too large for its body. It hops from rock to rock like it owns the place. It does. Because dinosaurs didn't really die. Not all of them. They shrank, took to the skis, and became something else. You see pigeons differently now, don't you? Time speeds up, forests regrow, mammals diversify, the world tries again. And yet, as you rise up above this recovering Earth, you can't help but feel a weight in your chest. We survived because something else didn't. That's a pattern you'll see again, unfortunately. Endings and beginnings tend to share a stage. The first time the world nearly ended, it did so with fire. The next time, it'll be ice. You inhale and the air feels oddly sterile, cool, high, thin. Then it thickens in your lungs like smoke without flame. You're standing on the edge of a caldera, 74,000 years in the past, staring into the yawning mouth of the Toba supervolcano. It doesn't look like much, just a lake nestled in Sumatra, peaceful as a vacation brochure. But beneath your feet, pressure builds like a clenched fist made of molten stone. And then the ground betrays you. It starts as a tremor, subtle, rhythmic, like the planet tapping its foot. Then the mountain groans. A sound you can't quite describe shakes the sky, as if the earth itself just coughed violently. And then Toba goes off. The explosion is not theatrical, it's apocalyptic. A mushroom cloud of ash and rock rockets over 25 miles into the sky. That's almost into space. You feel the shockwave flatten the jungle in every direction like a divine hand swiping clean a cluttered table. Birds, gone. Trees, gone. Herds of prehistoric animals. Ash sculptures in mid-step. It doesn't stop there. Over the next few weeks, Toba releases nearly 3,000 cubic kilometers of volcanic material. For context, that's enough to bury the entire United States ankle-deep in volcanic ash, or at least ruin everyone's weekend plans. The noise alone circles the globe multiple times. You lie flat on the ground now, eyes shut, ears ringing with thunder from the other side of the world. And as always, the real killer is what comes after. Historians still argue whether the Toba eruption almost wiped out humanity or merely greatly inconvenienced us. It's called the Toba catastrophe theory, and the core idea is this. The eruption caused a decade-long volcanic winter, dropping global temperatures by as much as 5 degrees C. That's enough to collapse ecosystems, trigger droughts, and squeeze human survival into a tight, icy bottleneck. You find yourself now walking across a different landscape entirely. The ash has settled, and the world is quiet, too quiet. You're in East Africa, which should be teeming with early Homo sapiens, but there's barely anyone here. Genetic studies suggest something eerie. Modern humans may have descended from just a few thousand individuals who survived this catastrophe. That's not poetic exaggeration. That's a literal number. Some estimates go as low as 3,000 breeding individuals. That's fewer than the number of people in a busy movie theater lobby. You walk through a camp now, barely more than a circle of stones and hides. Children with oversized eyes huddle close to weak fires. Their parents forage desperately for tubers and grubs. Food is scarce. The skies are gray. The stars have gone shy. The world feels abandoned, like a set after the show been canceled. These early humans, clever as they were, lacked the tech to fight back against a 10-year volcanic winter. But what they did have was adaptability, a longer childhood, cooperative social bonds, and vocal cords tuned to language. And so they wait, they share, they whisper lullabies in the dark and tell stories they don't yet have words for. Some of those stories will evolve into gods, flood myths, fire deities. But right now, they're just survival spells whispered into ash and wind. Meanwhile, in what will one day be India, the ashfall is meters thick. You walk knee-deep through it like fresh snow, except this stuff doesn't melt. It hardens. It preserves. Archaeologists in the modern world find these layers like time-sliced cake, geological proof of the day the sky fell. Want something bizarre? Some researchers have found microdiamonds in the Toba ash, tiny carbon crystals formed under the intense pressure of the eruption, little glittering remnants of horror, locked in stone. You sit for a while beside an extinct tree, watching a small band of humans chisel patterns into bones. Art is starting here quietly. Just scratches, yes, but meaningful ones. They're not just surviving, they're remembering. And while we're here, let's address that scholarly itch again. There's real debate over how much the Toba event actually affected global populations. Some scientists argue that genetic bottlenecks could have happened for other reasons: epidemics, migrations, maybe even just statistical weirdness. Others are more convinced that the volcano nearly wiped the human race clean off the board. Regardless, you now carry that legacy in your bloodstream. Every person alive today shares mitochondrial DNA that traces back to a few key ancestors. It's as if we all made it out of a burning house and haven't quite talked about it since. That's the uncomfortable truth. Your family tree has ashes in its roots. Now for your quirky tidbit. There are Indonesian myths, still told today, that speak of the day the mountains exploded and months without the sun. Oral histories that might be the cultural echoes of this prehistoric event, passed down through generations like heirlooms made of language. Whether they refer to Toba is speculative, but it's not impossible. Humans love to remember in riddles. Back on your feet now, you stumble through cold dawns and hungry nights. The volcanic haze is lifting slowly. You can almost feel warmth returning to the earth. Plants are regrowing. Game animals are returning to rivers and grasslands. You spot a child drawing something in the dirt with a stick, maybe a mammoth, maybe a god, maybe just boredom. The earth has pulled itself out of the spiral once again. And you're still here, sleepy, soot-smudged, slightly mutated, but here. You leave the Pleistocene behind with a strange respect for those who endured it. No bunkers, no canned beans, just fire, grit, and shared breath. But the next end-of-the-world scenario won't be natural at all. In fact, it will hinge entirely on the choice of one man sitting in a Soviet control room, staring at a blinking red screen. And it will be so close. You're blinking under fluorescent lights now. Everything smells like dust and metal. Somewhere, a low fan hums. The year is 1983, and you're sitting inside Serpukhov 15, a Soviet early warning bunker about 40 miles from Moscow. Your chair squeaks as you shift, but you're not alone here. Across the desk sits Lieutenant Colonel Stanislav Petrov, staring at a glowing console with tired, disbelieving eyes. The room looks like a Cold War movie set, all beige panels, blinking lights, and the anxious weight of global responsibility. The time is 12:14, the atmosphere, about as cozy as a root canal. And then it begins. A shrill alarm slices the silence. A red light flashes. Words appear on the screen. Missile launch DTCTD. Petrov doesn't move. Neither do you. The moment stretches impossibly long. The system reports that the United States has launched a nuclear missile. A minute later, it says 2, then 5. You lean over the console with him, reading what he reads. 5 Minuteman missiles heading toward the USSR. If true, Soviet protocol demands immediate retaliation. Launch on warning. Meaning, fire back before there's even land. The theory behind this was chilling in its precision. If the Americans launch first and you wait to confirm impact, your nukes might already be destroyed. So you have to guess. You have to trust the radar. And right now, the radar says the end of the world is inbound. Except Petrov hesitates. He doesn't sound the alarm. He doesn't notify his superiors. He doesn't flip the switch that could have turned this into the final, fiery extinction. Why? Because something smells off. He knows that if the US were actually launching a first strike, it wouldn't be 5 missiles. It would be hundreds, thousands. A full-scale assault designed to decapitate Soviet command. 5 is too small, too weird. And more importantly, the alerts are coming from a new satellite-based detection system, the OKO network, which had only recently been deployed. Petrov suspects a malfunction. He gambles everything, his career, his freedom, the future of human civilization, on a gut instinct. He reports it as a false alarm. You can feel his heartbeat, steady but loud. Minutes pass. The countdown to destruction never comes. The missiles don't arrive because they were never real. Turns out, sunlight reflecting off high-altitude clouds had tricked the satellite's sensors. A flaw in the system, a glitch in the matrix. Historians still argue whether the Soviets actually would have launched based on Petrov's report. Some say command protocols wouldn't allow a full retaliatory strike without additional confirmation. Others suggest that had someone more rigid, more frightened, more eager to follow rules been on duty, we might be living in a very different reality, or not at all. You stand beside Petrov now, watching as he exhales slowly and scribbles something into his logbook. He doesn't get a medal. He doesn't even get thanked. He's reprimanded for not properly filling out the paperwork. He'll later say he was just doing his job. Right. You follow him home in the early morning light. The air outside is crisp, cool. Moscow's streets are silent, unaware of how close they came to being ash. You stand by the window as he makes tea. The kettle whistles cheerfully, oblivious to its role in the post-apocalyptic fan fiction that never happened. There's something deeply unsettling about how easy it could have gone the other way. All the technology, training, and ideology in the world, and it still comes down to one tired man making a call at midnight. You shift perspectives now. It's 2025 again, and you're lying in bed, the ghost of that red alert still echoing in your mind. You start thinking about how many other near misses there have been. Nuclear bombs accidentally dropped from planes, malfunctioning radar systems misidentifying flocks of geese as incoming warheads. The infamous 1979 NORAD incident, when a training tape was mistaken for a real Soviet strike. Here's a quirky tidbit for you. In 1961, a US B-52 bomber accidentally dropped 2 nuclear bombs over North Carolina. One of them almost detonated. Multiple safety mechanisms failed, and only a single low-voltage switch prevented a mushroom cloud over the American South. There's still radioactive residue in the ground today. You lie there thinking, was the Cold War just a long, slow, bureaucratic suicide attempt with extra paperwork? It's easy to look back and marvel at how narrowly we dodged destruction. But remember, this wasn't ancient history. This was less than a lifetime ago. Petrov died in 2017, quietly, without much fanfare. Only later did the world start to acknowledge just how much we owed him. You sit quietly with that thought. A single man buried in a concrete room chose not to push a button. Sleep science tip for the evening. Your brain reacts to existential threat whether or not it's happening in real time. Even imagined global doom, like reliving a nuclear near miss, can raise your cortisol levels. So if your pulse is up, it's not the T, it's the tension. Breathe, you're safe, you're here. The sky is clear for now. Still, the Cold War left behind more than just decommissioned missiles and James Bond villains. It gave us a legacy of brinksmanship, paranoia, and buttons that still exist. Some of them are shinier now. Some have thumbprint scanners. Some are smaller and carried in suitcases. But they're all still here. As you start to doze, you feel yourself sinking back through the layers of time, deeper still. This time there are no missiles, no humans, just sun. You open your eyes again in the year 1859, and the sky is about to catch fire for real. You wake to an orange sky and the scent of ozone. There's a strange stillness in the air, like the Earth is holding its breath. You're in London now, but not the London you know. This one's horse-drawn, coal-smudged, and damp with Victorian fog. It's early September, 1859, and the locals are already muttering about strange lights in the heavens. You glance upward and pause. Auroras shimmer above the city, not green and gentle like the ones you've seen in travel documentaries, but red, blood red. Veins of electric crimson dance across the sky in silence, as if someone took a paintbrush soaked in solar radiation and smeared it across the stars. And it's not just London. All across the world, from Cuba to Queensland, the aurora blazes in places it has no business being. You're witnessing the Carrington event, the largest recorded solar storm in human history, and the wild part, it's about to get weird. It all starts 2 days earlier, on September 1st, when astronomers Richard Carrington and Richard Hodgson independently observe a blinding white flare erupting from the surface of the sun. They sketch it, squinting through their telescopes, unaware that this burst of light is a warning shot. A colossal coronal mass ejection, basically a solar fart of highly energized plasma, is heading straight for Earth at several million miles per hour. Usually, it takes solar material a few days to reach us. This one makes the journey in just 17 hours. You're standing inside a telegraph office now, watching in disbelief as sparks leap from the equipment. Operators are screaming, slapping out fires on their desks, while paper scrolls burst into flames. Some systems continue working even after they've been disconnected. Others deliver electric shocks to their operators. One poor fellow in Boston reports his telegraph machine is writing messages on its own. Spooky, sure. Supernatural, not quite. What's actually happening is the Earth, magnetosphere, a protective magnetic bubble, is being battered by charged particles from the sun. This geomagnetic storm is so intense that it induces electric currents in wires, railroad tracks, and even fences. It turns Earth into one giant, buzzing circuit. Historians still argue whether the Carrington event truly caused global chaos or if we've inflated it with modern hindsight. After all, in 1859, technology was limited. No power grids, no satellites, no airplanes. The main victim was the telegraph. But oh, what damage it could have done today. So let's imagine that for a second. You fast forward to now. Your phone buzzes, then dies, every screen flickers out. Satellites stop responding. GPS vanishes. Airplanes start circling in blind confusion, unable to navigate or communicate. Electric grids short out, transformers explode, and cities blink into darkness. This isn't science fiction. It's what would happen if a Carrington-level event hit Earth now. In fact, in 2012, we almost got a sequel. A CME of similar intensity missed Earth by just 9 days. The sun had rotated slightly by the time it burped out that particular fireball, so the storm zipped harmlessly past our orbit like an interstellar warning shot. You slept through it. We all did. NASA later described that near miss as close enough to ruin your weekend. Understatement of the decade. Back in 1859, people weren't sure what to make of it. Some thought it was the end times. Others just chalked it up to weird weather. There were even reports of gold miners in the Rockies waking up in the middle of the night, thinking it was morning because the auroras were that bright. They made coffee, saddled their horses, and only realized something was off when the sun didn't rise. Quirky fact time. The auroras were so intense that birds, confused by the light, began singing nighttime songs at noon, while night-blooming flowers opened in broad daylight. You sit now on a hillside outside Boston, the air electric against your skin. You can feel the low hum of the storm even without modern instruments. There's a pressure behind your eyes, a metallic taste in your mouth. and the sky is still lit up like a cosmic rave. It's beautiful, it's terrifying, it's easy to ignore because nothing truly broke. But here's the catch. We're far more vulnerable now than in 1859. Today, a Carrington-level storm could knock out power for weeks or even months in some regions. Think about that. No refrigeration, no internet, no running water in many urban areas. Hospitals forced onto backup generators that might fail. It's not just inconvenience, it's fragility. And you're probably thinking, why haven't we done something about this? Good question. Some countries have hardened their grid infrastructure. Satellites are monitored. There are space weather alerts. But solar storms are tricky beasts, sudden, unpredictable, and global. You can't just unplug the planet. And even if we had warning, we'd have just a day or two to prepare. Not enough. Sleepy side note. The same sun that gives you warm beach days and that nice golden hour for Instagram photos also occasionally tries to kill you. That's cosmic parenting for you. You breathe in slowly, watching the red aurora pulse overhead. You lie down on the damp grass. For a moment, the electromagnetic chaos becomes a lullaby. You imagine power lines buzzing like lullaby strings, playing a silent warning to those who will come centuries later. Carrington himself never lived to see the legacy of his storm. But every time scientists name-check him in solar storm literature, he gets another whisper of recognition. And so do you. Because you were here for this one. You stood inside the magnetic ripple. You smelled scorched ozone. You felt the Earth's skin shiver. But the next extinction flirtation won't come from the sky. It'll come from a much smaller, much itchier source. You're sweating. The air is thick with incense and something darker, something sweet-rotten and unmistakably wrong. You're back in the 14th century now, somewhere in Europe. Doesn't matter exactly where. Venice, maybe, or London, or Constantinople. The symptoms are the same, the dread is universal, and the smell, that's global. This is the plague. But not just a plague. This is the plague, the Black Death. The bubonic horror that reduced the world's population by 1/3 in just a few years and left behind more open graves than answers. And you're standing right in the middle of it, watching as masked physicians, beaked and black-robed like birds of ill omen, shuffle past you with bundles of herbs clutched to their chests. They look like characters from a nightmare, but they were the frontline defense against a microscopic killer. Yersinia pestis, a bacterium hitching rides on fleas, and those fleas on rats, and those rats on ships, and those ships to everywhere. People say don't let the bedbugs bite, but honestly the fleas were far worse. You follow one now, a little black speck darting through the fur of a rat in a merchant's cart. Harmless at first, then hungry. One bite and it begins. Fever, swelling lymph nodes, buboes under the arms and groin, dark as bruises, hot as coals. Within days, the victim's skin blackens, hence the name. And then silence, often in just 3 to 5 days. You visit a home, one person sick, by morning 3. By the end of the week, all of them wrapped in cloth and carted to a mass grave, bell tolling softly in the distance. No goodbyes. No last rites, just lime and dirt. And yet, despite the horror, the Black Death didn't quite end the world. But it tried. Historians still argue whether the plague originated in Central Asia, China, or somewhere else entirely. What we do know is that it traveled the Silk Road, stowing away like a very unwelcome backpacker, and reached Europe in 1347, via Genoese trade ships docking in Sicily. Within 2 years, it had torched through most of the continent like wildfire through parchment. And then it kept going. The Mongol armies may have helped. Some records, though fringe, suggest a grim kind of early biological warfare. Besieging forces in Crimea reportedly catapulted plague-infected corpses over city walls to infect the defenders. Whether that happened exactly as told or not, it's delightfully gruesome to imagine. Take that, and also, here's Dave's corpse. Meanwhile, in cities and towns, entire social structures crumbled. Priests refused last rites, families abandoned their sick, farmers stopped farming, graves ran out of space. You pass one now, just a trench with dozens of bodies stacked like firewood. A friar tosses in another, muttering a prayer with mechanical detachment. You nod politely. He doesn't see you. Then something strange begins to happen. With so many dead, the survivors start to thrive. Sort of. Labor shortages mean wages rise. Land becomes available. The rigid medieval class structure begins to crack. You walk through a town square where a peasant argues with a nobleman and wins. The world didn't end, it reshaped. But even so, the death toll is staggering. Some estimates put it at 75 to 200 million. That's a lot of funerals to skip. Entire villages vanish from the map. In places like Florence, it's said that up to 80% of the population perished. Chroniclers wrote that there were not enough living to bury the dead. Others stopped writing altogether. Here's a quirky little wrinkle for your bedtime brain. The nursery rhyme "Ring Around the Rosy." Some people believe it refers to the plague. Rosy for the rash. Pocket full of posies for the herbs. Ashes, ashes. Well, you get the idea. Though historians still debate whether the rhyme actually originated in plague times or centuries later, it's one of those eerie cultural echoes that refuse to fade. But the plague wasn't a one-hit wonder. It came back, again and again, every few decades for centuries. Smaller outbreaks, yes, but brutal, like a horror franchise that didn't know when to quit. And then in the 1890s, it reinvented itself. Welcome to the third pandemic, which began in China and spread globally thanks to modern shipping routes. This time, it hit India hard with over 12 million dead. And with it came another twist, pneumonic plague, a version that spreads through the air. Forget fleas, just breathing near someone was enough. Suddenly, the idea of staying indoors, wearing masks, and avoiding human contact started to sound very familiar. Sound like 2020. Yeah, some lessons come back in different outfits. You walk past a house now, boarded shut, a white cross painted on the door. Inside, someone coughs softly. No one comes to help, not anymore. But humans are stubborn. Eventually, we fought back. Not with swords or sermons, but with antibiotics. In the 20th century, sulfa drugs and later streptomycin gave us a way to survive, to contain, to control. We turned the plague from a civilization-ending monster into something manageable. Not gone, mind you, still hiding out in rodent populations around the world, but quieter. Even today, a few cases pop up in the American Southwest every year, usually linked to prairie dogs, which means yes, technically, you could still get the Black Death, but now we've got meds and Google. So as you lie back in the candle-lit gloom of this medieval alleyway, eyes half shut, consider this. Humanity didn't just survive the plague, it changed because of it. Art got darker, science got bolder, religion got complicated. You could argue that the Renaissance was born in the graveyard of the Black Death. You can smell it now, rosemary and lavender, crammed into beaked masks by well-meaning doctors who had no idea what a bacterium was. But they tried, and sometimes trying is all we have. Sleep now, the rats have quieted, the bells have stopped. But the next time the world nearly ends, it won't be because of sickness or flame. It'll be ice. Your feet crunch across an endless plain of snow and ice. There's no wind, no bird song, no trees to creak, no rivers to babble, just silence deep, ancient, and wide as eternity. This isn't winter. This is a planet in deep freeze. Welcome to Snowball Earth. Not a snowball, the snowball. Roughly 650 million years ago, long before trilobites, ferns, or anything with a skeleton, the Earth decided to try out a new aesthetic: frozen marble chic. Ice stretched from pole to equator. Oceans froze. Mountains wore glaciers like fur coats. And the tropics, same temperature as present-day Antarctica. You walk for miles and see no sign of life, at least not above the surface. The entire planet is locked in what scientists call a global glaciation. Think the Ice Age, but turned up to 11, with the thermostat superglued in place. You reach a coastline, though the term feels generous. The ocean is frozen solid, the surface as smooth as polished glass. Beneath that ice, somewhere in the darkness, life still flickers. Barely. This wasn't the first time Earth flirted with freezing over. Geologists believe there may have been multiple snowball Earth events during the Neoproterozoic era. Some suggest they lasted millions of years. Imagine an ice age that doesn't just come and go. It moves in, rearranges your furniture, and demands rent. So what caused it? Historians, paleoclimatologists, still argue over the exact trigger. Some point to volcanic eruptions spewing reflective aerosols. Others suggest a sudden drop in greenhouse gases, possibly due to weathering of newly formed mountains. One fringe theory even implicates the rise of early photosynthetic organisms. Think about that. Algae accidentally pumping out so much oxygen that they triggered a planetary shutdown. Whoops. You pause beside a cliff, studying banded rocks called cap carbonates. These strange deposits are found directly above glacial layers around the world, and their presence supports the snowball Earth hypothesis. They suggest that after millions of years of cold, the planet suddenly thawed, and with it came a bizarre bloom of carbonates, like a frozen soda bottle exploding after being opened. But more on that in a minute. For now, you focus on staying warm. Even though you're just a guest here, watching through the frosted lens of time, your body tenses against the imaginary chill. The silence is unnerving. There are no footprints in this snow except yours. No stars visible through the thick atmosphere. Even the moon, just a little closer in this epoch, looks pale and disinterested. And yet life survives. Down beneath the ice, in thin slivers of ocean left unfrozen, microbial communities cling to hydrothermal vents, those deep-sea chimneys spewing warmth and minerals from the Earth's molten guts. You float down now, watching bacteria shimmer in the dark, gobbling sulfur and carbon, unfazed by the apocalypse above. This is where it all begins. These humble, heat-loving microbes form the bedrock of survival. They don't need sunlight. They don't need fresh air. They just need chemistry, and they're proof that life doesn't die easily. It adapts. It waits. It schemes. Here's your quirky tidbit. Some of the earliest fossils from this period are stromatolites, layered mats of cyanobacteria that grew in shallow seas. During snowball Earth, those shallow seas mostly disappeared, yet stromatolites somehow hung on. Today, you can still find living examples in places like Shark Bay, Australia. Nature's very own do not die posters. So how did the planet thaw? One word: volcanoes. You climb a rocky ledge now, where a violent eruption is painting the snow black with ash. For millions of years, volcanoes kept belching out carbon dioxide, but with the planet sealed in ice, there was no weathering to draw it back down. The carbon built up little by little, like a global greenhouse slowly pulling the blinds shut. And eventually, the tipping point came. You watch it happen. The atmosphere thickens, temperatures rise, ice begins to crack, then melt. Sea levels surge. Methane locked in permafrost bursts free in wild, giddy plumes. The snowball becomes a slush ball and then a steamy, tropical mess. You're sweating now, standing in what was once glacier. The heat is oppressive, the shift abrupt. And in the wake of that melt comes something extraordinary, an explosion of life. The snowball Earth period may have set the stage for the Cambrian explosion, a time when multicellular organisms evolved rapidly, diversifying into the ancestors of basically everything complex, including you and your cat, and that one guy in accounting who microwaves fish. Historians still argue whether the extreme conditions of snowball Earth caused the explosion or just created a clean slate. Either way, you wouldn't be here without the ice. There's something poetic in that, isn't there? That from total stillness came total possibility. As you sit now beside a thawing pond with strange microbial mats beginning to wrinkle the surface like protolilipads, you hear the planet exhale, not metaphorically, a literal hissing of gases escaping as the ice recedes. Earth is waking up, its long nap over. You hear frogs that don't exist yet, trees that haven't evolved, dreams that haven't been dreamed. You think back to the nights when you complained about cold toes, drafty windows, and losing Wi-Fi during a snowstorm. And now you realize those weren't real cold snaps. This was. And yet life endured, not because it was strong, but because it was small and stubborn and just clever enough to hide in the deep places. The lesson is oddly comforting. You lie down now in the melted silence. The wind smells like sulfur and salt. The sky is pale blue again. Somewhere in the shallows, a multicellular blob is preparing to split and become something no one ever seen before. You close your eyes, the world didn't end, it just rebooted. But the next extinction, it won't freeze or burn. It will drown. The air is sharp and clean, unnervingly so. You take a breath and immediately regret it. Your lungs burn, not from smoke or ash or cold, but from oxygen. Not the gentle 21% you're used to, but something much more intense. You're standing on a shoreline nearly 3 billion years in the past, and you've just inhaled the aftermath of Earth's first mass poisoning. Congratulations, you've stumbled into the great oxygen catastrophe. Don't let the name fool you. This was no Hollywood disaster movie. There were no tidal waves, no alien invasions, no dramatic fireballs. Just gas. Invisible, odorless, and lethal to nearly every form of life on the planet. You sit down beside a shallow pool, watching it bubble gently under the sun. The surface is coated with a strange, iridescent slime, cyanobacteria, unimpressive at first glance. No teeth, no brains, no complex organs, just floating, globby mats that sunbathe for a living. And yet, these little green overachievers are about to change everything. Using a process we now call photosynthesis, they start pumping out oxygen as a byproduct. Not much at first, just a trickle, but over millions of years, those trickles become floods. At first, this oxygen is soaked up by iron in the oceans, forming massive rust-colored deposits that later become banded iron formations, the stuff we mine today for steel. You walk past a cliff now, its layers like a giant's fingerprint, striped red and black, a permanent geological receipt for what these microbes did. But eventually the sponge gets full. The oceans can't absorb any more oxygen, and neither can the volcanic gases in the air, so the oxygen builds up, slowly, relentlessly. And for most life on Earth at the time, anaerobic microbes that had thrived in a low-oxygen environment, it's the equivalent of flooding the atmosphere with bleach. They die in droves. You float down into a one steaming microbial mat, now dissolving in a chemical stew of its own making. It's a massacre without screams, a genocide written in bubbles. No fossils are left behind, only gaps, sudden absences in the rock record where diversity once swam. Historians still argue whether this qualifies as Earth's first mass extinction. Some say yes, it wiped out a massive swath of anaerobic life. Others hesitate, nodding that we lack the fossil record to be certain. But even if the victims remain anonymous, the scale of the crime is undeniable. The killer, oxygen, which is a little awkward because you're breathing it right now. You walk along the edge of a newly oxygenated sea. The water is still anoxic below the surface, dark, iron-rich alien. But just above, a fragile atmosphere is forming, one that will eventually support things with spines, lungs, and to-do lists. But the transition is far from smooth. As oxygen levels rise, the planet enters a deep freeze, the Huronian glaciation. Some think this is connected. The oxygen destroyed atmospheric methane, a powerful greenhouse gas, and Earth's thermostat crashed. You remember this cold. You've walked it before. That was Snowball Earth. This might have been its prototype. So to review, tiny blue-green microbes invented photosynthesis, turned Earth into a toxic hellscape, murdered most of their microbial neighbors, and triggered an ice age. And we call them simple life. You sit now at the base of a newly forming mountain range, your hands stained red with oxidized iron dust. The air feels thin, almost surgical in its sterility. It's strange to think of oxygen as anything but life-giving, but here it's still adjusting, still learning to be helpful. Here's your quirky tidbit for the night. Some scientists suggest that it took nearly 1 billion years after the first oxygen burst for Earth's atmosphere to become stable and breathable. For nearly a third of the planet's history, oxygen levels fluctuated wildly, like a toddler learning to walk, or set things on fire. Because fire, that's a side effect of all this progress. You look ahead now, deep into Earth's future. Fire will one day become possible. Forests will burn, lightning will ignite dry grasslands, and eventually, one very clever ape will figure out how to roast marshmallows. But all of that begins here, in this weird, slimy epoch where the most dangerous thing in the world was the breath of something you can't even see. And the drama doesn't stop. The oxygen that nearly killed everything. It's also what makes complex life possible. With more efficient energy metabolism, organisms can grow bigger, build tissue, think, move, scream. And from that chaos emerges a lineage that will eventually build rockets and spreadsheets and emoji keyboards. You press your hand into a patch of purple microbial goo. It shivers slightly but does not resist. This is where you started. This is your great-great-great-great-grandparent if you trace back far enough through the family reunion of time. And it probably hates your guts. Because you're filled with oxygen. You're living proof that the survivors of the catastrophe not only made it, but turned their trauma into innovation. Sleepy side note. Modern humans actually need oxygen, but in the wrong concentration, it still becomes toxic. Divers know this. Astronauts too. Even premature babies in neonatal units have to be carefully monitored. Life is a narrow window, and we're forever perched on its sill. You close your eyes again, drifting through the haze of this ancient world. Somewhere above, volcanoes still hiss. The sky is not yet blue. It's a weird orange pink, painted by gases your lungs wouldn't tolerate for more than a breath. And yet everything is becoming, not ending. The oxygen catastrophe wasn't the end of the world, just the end of a version of it, one that had no color, no breath, no fire. You exhale slowly, oxygen whispering out through your nose. Somewhere a cyanobacterium smiles, probably. But don't relax just yet, because the next near ending is already happening. And this time it's us. The forest is silent, not peaceful silent, empty silent. You tread softly across leaf litter that should be crawling with life, beetles, worms, little flickering frogs, but it is. A few birds still chirp in the canopy, but they sound tentative, as if singing just out of habit. You're not in the past anymore. You're here. Now, present tense. Welcome to the sixth extinction. It's not as dramatic as the others. No asteroid, no lava flows, no blood-red skis. But don't let that fool you. This one's quieter, slower, smarter. It wears lab coats, builds highways, grows crops. And unlike the other catastrophes, this time we're the asteroid. You crouch beside a fallen log. Once, this would have been a bustling hub of life. Fungi, millipedes, lizards darting into shadows. Now it's just wood. Dry, hollow. You run your hand over the bark and feel the cracks like wrinkles. The log, like the forest, has stopped speaking. Species are vanishing at a rate that even conservative scientists find unnerving. A normal background extinction rate, based on fossil records, is maybe 1 to 5 species per year. Current estimates put the modern rate at 1,000 times that. Some say more. Historians still argue whether we're officially in a new mass extinction or just spiraling toward one, but the trajectory is hard to deny. You walk further now through a jungle that once teemed with megafauna. No more saber-toothed cats, no more woolly rhinos, no more giant ground sloths as big as minivans. Gone, most within the last 10,000 years. Coincidentally, around the same time, humans started showing up with pointy sticks and a suspicious look in their eyes. But that was just the prologue. Today's extinction event is fueled by more sophisticated tools: chainsaws, pesticides, overfishing trawlers, palm oil plantations, warming oceans, expanding cities, and yes, plastic. You kick a discarded bottle at the edge of a river. It's not breaking down. It'll outlive you, maybe even outlive your species. And still, this isn't about evil or malice. It's about scale. There are over 8 billion of us, and our collective shadow stretches into every ecosystem. You dig a hole in Antarctica and find microplastics. You net a fish in the Mariana Trench and discover mercury in its blood. You listen for frogs in the Amazon and hear nothing. Quirky fact to file away. Scientists recently declared the bramble key melames, an obscure rodent from a tiny island near Australia, as the first mammal to go extinct due to climate change. Its home was swallowed by rising sea levels. A single species, gone in a few silent waves. But it's not just the obscure ones. You watch as pollinators vanish, coral reefs bleach and crumble, amphibians croak their last. Insects, a cornerstone of every food web, are disappearing so rapidly it's been called the insect apocalypse. You think we'd notice. We haven't. Still, you're not completely alone out here. A researcher kneels by a tree tagging a bat. Another logs data on disappearing orchids. Someone else is strapping GPS to elephants to stop poachers. The human story is always complicated. Yes, we cause damage, but we also write field guides, fund sanctuaries, and weep over extinct birds we never met. You sit on a rock now, watching the sun filter through a thinning canopy. There's a term for this moment: shifting baseline syndrome. Each generation forgets what normal used to look like. You grew up with fewer birds, so that becomes your baseline. Your grandparents remember skis blackened by flocks of passenger pigeons. You'll never see that. You didn't even know to miss it. And that's how it happens. Loss becomes invisible. Historians of the future, if they're around to write anything, will probably find this part the most surreal, that we knew it was happening in real time, that we had charts and graphs and Netflix documentaries, that we taught children about endangered species while approving oil pipelines, that we threw benefit concerts for the rainforest while eating burgers wrapped in rainforest. You're walking now through a museum that doesn't exist yet. Its halls are lined with taxidermy, tigers, pangolins, rhinos, vaquitas. Next to each is a plaque that begins with, "Once widespread." In a corner exhibit, a hologram recreates a coral reef. The colors are so bright you forget they're fake. A kid nearby tugs at their parent's sleeve, asking, "Did people really swim with those?" The parent nods solemnly. Neither knows how to process it. But it's not all doom. Seriously. You climb now into a rewilded zone, places where humans have backed off just enough for life to try again. Wolves in Yellowstone, bison on the plains. Even Chernobyl, ironically, has become an accidental wildlife refuge. Give nature a crack of space and it rushes back in like water through a broken dam. Here's a thought to ease your pulse. Extinction is forever, yes, but collapse is. Forests regrow, reefs can recover, species can return if we let them, or even help. Some scientists are already flirting with de-extinction, editing genomes, reviving lost traits. Woolly mammoths, passenger pigeons, Tasmanian tigers, all names whispered in labs like forbidden magic spells. Historians still argue whether we should bring back extinct animals or just stop killing the ones we still have. It's a debate that blends ethics, ecology, and Jurassic Park references in equal measure. You lie back now, the forest canopy above you flickering like a faded constellation. Somewhere a bird calls, a real one for now. Its song is simple, pure. You listen, wondering how long it's got left. You exhale. The world hasn't ended. Not yet. But it is quieter and emptier and changing fast. And next. The next time the world nearly ends, it won't even touch the ground. It'll explode in the air. You're floating now over a forest of pines. Below you, the trees stretch out like green fur on the back of the earth, peaceful and undisturbed. It's 1908 and you're somewhere deep in central Siberia near the stony Tunguska River. The morning is crisp. Birds chirp. A breeze stirs the needles. You breathe in, and for a second you could almost mistake this for serenity. Then the sky explodes. No warning, no sound at first, just a sudden bloom of blue-white fire high above the treetops, a second sun, then boom. The blast rips through the air with the force of 1,000 Hiroshima bombs. Trees collapse outward from a central point, like a child pressing down on a patch of tall grass. 2,000 square kilometers of forest flattened in an instant, some 80 million trees. You hover, stunned, over what looks like a giant fingerprint scorched into the face of the earth. And yet, miraculously, there's no crater. This is the Tunguska event, a near-extinction level airburst caused by a cosmic visitor, most likely a stony asteroid, perhaps 50 to 60 meters wide, that disintegrated in the atmosphere about 5 to 10 kilometers above the ground. It never hit the Earth. It didn't need to. Shockwaves rippled across continents. People hundreds of miles away felt the blast. Windows shattered in Siberian villages. In London, barometers twitched. Seismic instruments as far away as Washington, D.C. recorded the tremors. And yet, for all this drama, the rest of the world mostly shrugged. Remote wilderness. No big deal. But you know better. You walk now through the aftermath. The trees all lie pointing away from the explosion's epicenter. Not burned exactly, just snapped. A scorched butterfly print etched into the taiga. You pass reindeer carcasses and overturned sleds. Entire nomadic camps vanish in silence, their stories lost to the wind. Historians still argue what exactly caused the Tunguska event. The asteroid theory is most widely accepted, but others have proposed a comet nucleus, made of ice, not rock, that exploded before impact. And then there are the fringe theories, miniature black holes, rogue antimatter, even alien ships suffering catastrophic warp core failures. As always, the best disasters attract the weirdest fan clubs. It wasn't until nearly 20 years later, in 1927, that an actual scientific expedition reached the site. Led by Leonid Kulik, the team trudged through mosquito-choked bogs and muddy rivers to survey the devastation. What they found only deepened the mystery. No impact crater, no fragments, just flattened forest and folklore. Locals still whispered of a god's punishment, or the sky falling in fury. And here's a quirky fact for your memory drawer. The Tunguska explosion was so powerful that, for several nights after, skies across Europe and Asia glowed with strange lights. In London, people reported being able to read newspapers outside at midnight without a lamp. No one understood why. The newspapers mostly blamed atmospheric weirdness, because that's what you do when you don't want to talk about the sky blowing up. You sit now at the supposed epicenter, where a single patch of scorched trees still stands upright, oddly untouched. Scientists call it the telegraph pole forest. Its existence makes little sense. Why would some trees near the blast survive while others far beyond fell like dominoes? One theory is that the shockwave came straight down, compressing the trees rather than toppling them. It doesn't really matter. The point is, this thing missed us by a hair. Imagine if it had exploded over a city, London, New York, Tokyo. Imagine 2,000 square kilometers of civilization wiped clean in a single breath. The death toll, unimaginable. The global reaction, total panic. The long-term effect, who knows? Tunguska is Earth's polite extinction that didn't happen, the one that landed in the middle of nowhere, the warning shot. But did we listen? You drift back to modern times. Satellites now scan the skies for near-Earth objects, NEOs, tracking thousands of asteroids and comets that pass close to our orbit. Some, like Apophis and Bennu, have their names whispered in conference halls with just the faintest edge of concern. In 2013, a smaller asteroid, only about 20 meters wide, entered Earth's atmosphere and exploded over Chelyabinsk, also in Russia. Sound familiar? It should. This one injured over 1,500 people, mostly from shattered glass. Once again, we got lucky. Still, as of now, we have no global system in place to deflect an asteroid. No Bruce Willis drilling team. No giant planetary shield. Just spreadsheets, tracking software, and crossed fingers. Sleep science sidebar. Your brain is hardwired to fear fast, dramatic threats, lions, gunshots, pop quizzes, but slow, statistical, abstract threats. Those lull you into dangerous calm. And Tunguska, that's the latter, big, quiet, easy to forget. But the trees remember. You lie now on your back in the heart of the flattened forest, staring up at a perfectly normal blue sky. No fireball, no warning, just the knowledge that space doesn't care, and it will try again. You run your hand across a tree trunk bleached pale by decades of sun and snow. It's hollow now, filled with moss. A soft bed for insects that wouldn't exist if that rock had hit 15 minutes earlier, or 100 kilometers south. The line between survival and extinction is that thin. You close your eyes, the wind stirs the grasses. In the quiet, you can almost hear it, the earth sighing in relief. But the next extinction theory, let's just say it burps. You're underwater now, not in a pleasant, tropical snorkeling way, but deep, eerie, and ancient. The ocean floor stretches out beneath you like a sleeping beast, rippled and cracked, its silence broken only by the occasional gurgle of escaping gas. You drift past a mound of dead clams, dozens, maybe hundreds, just sitting there, sealed like little sarcophagi. You're in the shadow of something called the methane burp hypothesis. No, not a joke. This is serious flatulence. Roughly 55 million years ago, something very strange happened. Global temperatures spiked by 5 to 8 degrees Celsius in just a few thousand years. The oceans turned acidic, ecosystems flipped out, and entire groups of organisms went extinct, including many deep-sea creatures that had survived all previous climate jolts. This moment is called the Paleocene-Eocene thermal maximum, or PETM, and scientists still argue what triggered it. Was it volcanic activity, thawing permafrost, a comet impact, one particularly gas-prone dinosaur? But one theory stands out, partly because it's both ridiculous and terrifying: a sudden release of methane from the ocean floor. You land now on the edge of a frozen slope, where methane hydrates, gas molecules trapped in a lattice of ice, are buried just below the seabed. Under normal conditions, they stay stable, locked in place by pressure and cold. But warm the oceans even a little and they start to bubble. And then burp. Imagine billions of tons of methane erupting into the atmosphere in a geologic instant. Methane is a greenhouse gas 25 to 80 times more potent than CO2 over short timescales. Release enough of it and you've got yourself a planetary hotbox. Oceans overheat, coral reefs die, rainforests turn into dry forests, polar regions melt. You blink now and the ocean vanishes. You're on land, trudging across a swampy, steaming earth. The poles are tropical. Crocodiles swim where ice once ruled. Tiny horses, actual species no bigger than house cats, pick their way through ferny undergrowth, adapting fast to the heat. Everything looks stressed. Historians still debate whether the PETM counts as a mass extinction. It didn't wipe out as many species as the Big Five, the traditional Hall of Fame extinctions, but it did mark a turning point. Life didn't die off so much as scramble, migrate, shrink. Deep-sea ecosystems took hundreds of thousands of years to recover. You touch the shell of a foraminifera, those tiny plankton that record Earth's chemical history in their chalky shells. During the PETM, their species diversity plummeted. They're like the canaries in the planetary coal mine, and in this case, they all fell silent at once. Now here's the twist you knew was coming. Something eerily similar might be happening again. Because methane hydrates, still here, still lurking in the permafrost of Siberia, still buried under the Arctic seabed. As the climate warms, those same icy cages are starting to wobble. In recent years, scientists have discovered methane bubbles rising through thawing lakes in Alaska and Siberia, little fizzing pools that smell like Earth has indigestion. One quirky tidbit: you can light some of these bubbles on fire. Arctic researchers have filmed themselves holding lighters over holes in the ice and igniting jets of methane like party tricks from the end of the world. Science, but make it oof. You sit now beside a small boreal pond, watching bubbles rise through the water. They're hypnotic, gentle, almost pretty, but you know what they mean. The line between PETM and 2025 isn't as wide as we'd like. You think of the term climate feedback loop. Ice melts, oceans warm, methane releases. The atmosphere traps more heat, ice melts faster. You get it. The loop feeds itself like a snake swallowing its own tail, except the tail is on fire and the snake lives in your basement. But even if the methane burp hypothesis isn't the whole story of the PETM, it's a compelling reminder that the Earth has stored disasters tucked away, like an attic full of bad decisions. All it takes is the right nudge. You stretch now, warming your hands by a geothermal vent. A shrimp scuttles past, unbothered. Life always finds a niche even here, but the niches are fewer, the timelines shorter. Historians still argue whether the PETM triggered long-term changes in mammal evolution. Some point to dwarfing trends, animals shrinking in size to deal with heat and food shortages. Others think it was just a blip, but either way, the lesson stands. Rapid climate change doesn't wait for permission. It rewrites the script. And you're in the third act. You rise now into the stratosphere, looking down on Earth's patchwork biosphere. From up here, it's impossible to see extinction. Everything looks fine. Blue oceans, green continents, white clouds, a marble spinning quietly through space. But you know better. You've seen the clams. You've smelled the methane. You've watched the oceans forget how to breathe. Sleep tip of the evening. Your brain responds differently to natural sounds. Rain, ocean waves wind through trees. They trigger the parasympathetic nervous system, the one that says you're safe. That's why you fall asleep to the sound of water. But sometimes, that water is boiling. You close your eyes, bubbles rise, the earth hums with memory. And the next disaster, it arrives on a whisper and a cough. The air is dry, sharp with disinfectant and heavy with breath. You're in a crowded hallway, dim, echoing, and full of the sounds of muffled voices and dragging feet. The year is 1918, and the whole world is coughing. Welcome to the Spanish flu. You duck as a gurney wheels past, pushed by a nurse in a white smock, her mouth covered by a gauze mask that's already soaked through. The patient on the stretcher isn't old or frail. He's young, pale, barely 30. Blood has begun to seep from the corner of his mouth, but no one reacts. Everyone's seen worse. You step into the ward. Cots stretch wall to wall, shoulder to shoulder, bodies lined up like passengers on a ghost train. Some moan, some lie still. A few stare upward as if watching something approach, something final. You're inside one of the deadliest pandemics in human history. And weirdly, most people today barely remember it. The Spanish flu of 1918 killed an estimated 50 to 100 million people, more than World War I, which had just wrapped up that same year. It spread faster than any disease in recorded history, moving across continents in weeks. Why? Because the world, for the first time, was deeply interconnected. Armies, trains, ships, all perfectly efficient disease vectors. You walk beside a line of soldiers boarding a train in Kansas. One of them coughs into his sleeve. Another wipes his nose. None look concerned, but that train is heading to a military base, and from there, Europe and beyond. Here's the twist: it probably didn't start in Spain. Historians still argue the exact origin. Some say Kansas, some say France, others suggest northern China. But Spain got the name because it wasn't censoring its press. Unlike the US or Britain, Spain wasn't at war, so when flu cases exploded, the Spanish papers reported honestly, and the name stuck. You lean against a lamppost now in Madrid, reading a headline: King Alfonso XIII bedridden with influenza. That's how the world first heard about it, through a royal sneeze. You walk through cities where the flu has shut everything down. Schools closed, churches shuttered, funeral homes overwhelmed. There's a smell in the air again, not rot but lye and vinegar. People soak their handkerchiefs in it, believing it might help. And here's what makes this flu truly chilling: it killed the young and healthy. Most influenza strains hit the elderly hardest, but this one triggered something called a cytokine storm, a violent overreaction of the immune system. The stronger your immune response, the worse your symptoms. Imagine that, your own body panicking itself to death. You pass a woman on her knees praying through a locked church door. Her hands tremble. She's wearing a charm around her neck, a mix of silver and clove, a folk remedy. it won't help. In Philadelphia, the city had just held a massive war bond parade. 200,000 people attended. Within 72 hours, every hospital bed was filled. In less than 2 weeks, over 12,000 people were dead. You sit in a schoolhouse converted into an emergency ward. Children lie side by side, some sharing oxygen tubes cobbled together from makeshift parts. A nurse walks past you, scribbling names onto toe tags. She doesn't flinch anymore. Quirky fact for the night: some families painted their windows with red crosses to signal the flu had already visited, an early version of the Do Not Disturb sign. Others stuffed garlic in their pockets or wore mustard plasters across their chests. Nothing worked. And the worst part, it came in waves. The first wave early in 1918 was bad, but survivable. The second wave in the fall was apocalyptic. You're there now, outside a morgue where bodies are stacked like firewood, wrapped in blankets because there aren't enough coffins. Horses drag carts through the streets, collecting the dead. Newspapers print lists of names so long you stop reading halfway through the page. You breathe in slowly. You can almost feel the virus, microscopic, spiked, and mindless, leaping between hosts. On your shoulder, in your throat, it doesn't think, it doesn't hate, it just spreads. But here's the strange comfort. This wasn't the end of the world. It was a disaster, yes, but not extinction. Humanity bent but didn't break. People wore masks, stayed indoors, organized volunteers to help the sick. It was chaotic, inconsistent, and full of contradictions, just like now, but we got through it. Eventually. Historians still argue why the flu eventually faded. Herd immunity, mutation into a milder form, interventions that, while imperfect, slowed the spread, probably some mix of all three. By 1920, it was mostly over. No vaccine, no antiviral treatment, just time and loss. You now sit in a quiet house where 3 of the 5 occupants have died. The mother is hanging wet sheets soaked in eucalyptus over the windows. She reads a Bible passage aloud, her voice shaking. She isn't religious. She's just scared. And just as suddenly, you're back in your own bed, staring at your ceiling. The world outside is modern again, but your mind still echoes with footsteps on hospital floors and whispered goodbyes. You remember 2020, don't you? Of course you do. That soft chaos, the masks, the silence, the Zoom funerals. This has happened before, and before that, and before that. Pandemics aren't new, but neither is resilience. The Spanish flu didn't end the world, but it did leave a scar, one we forgot far too quickly, a silence where a warning should have been. You close your eyes. The earth spins quietly beneath you. Somewhere, a scientist is tweaking a new mRNA formula. Somewhere else, a child blows out birthday candles without a mask for the first time in years. But don't get too comfortable, because beneath your pillow tonight is a heartbeat. And under that, a supervolcano. You're lying on sun-warmed ground now. Grass brushes your fingers. A gentle breeze smells of pine and sulfur. It feels like summer in Wyoming, birds overhead, elk in the distance, tourists snapping photos of geysers without realizing they're standing on top of a ticking bomb. This is Yellowstone. You sit up and the meadow stretches wide and peaceful, framed by snow-dusted peaks and gentle valleys. There's a buffalo lounging 10 feet away from you, snorting lazily. It has no idea it's grazing on one of the largest supervolcanoes on Earth. Neither do the tourists. That's the thing about Yellowstone. You'd never know what's underneath. Until it's too late. You walk through the park, past geysers and hot springs, steam rising from rainbow-colored pools. These aren't just pretty attractions, they're pressure valves, vents, places where the planet exhales. But beneath your feet, miles down, sits a magma chamber so vast it could swallow whole cities. And if it decides to wake up, well, you might not want to be holding a selfie stick. Let's be clear. Yellowstone has erupted before. 3 times in the past 2.1 million years, it's blown its top in cataclysms so huge they altered the global climate. The first, 2.1 million years ago, created the Huckleberry Ridge Tuff and formed a caldera 75 kilometers wide. The second, 1.3 million years ago, was smaller, but still massive. The third, around 640,000 years ago, was the big one. It created the current Yellowstone caldera, blasted over 1,000 cubic kilometers of ash into the sky, and left behind the steaming, restless wonderland you see today. Historians still argue whether another super-eruption is overdue. The phrase gets tossed around a lot. It's been 640,000 years, so maybe we're due. But geology doesn't keep a schedule. Supervolcanoes don't use calendars. You now stand at the rim of a mud pot watching it bubble. It smells like rotten eggs and something worse. A ranger passes by, cheerfully explaining that earthquakes happen here all the time, over 1,000 small ones per year. Keeps the magma moving, she says. You smile, she smiles. No one mentions what would happen if it stopped moving. Here, what it could look like if Yellowstone blew tomorrow. First, a series of earthquakes, small at first, then larger. Geysers would go quiet or erupt erratically. The ground might rise in places, swell like bread in an oven. And then, boom! Not one of those cute lava fountain eruptions like in Iceland. We're talking ultraplinian eruption, the kind where the top of the mountain doesn't just crack, it vanishes. A plume of ash and gas would rise into the stratosphere, blacking out the sun across parts of North America within hours. Shockwaves flatten forests. Pyroclastic flows, superheated clouds of ash, gas, and rock, race across the landscape at hundreds of miles per hour. The blast zone, gone. Everything within a 100-mile radius simply erased. But it's not just a local event. Ash would fall across most of the continental U.S. inches thick in some places, enough to collapse roofs, contaminate water and ground air travel for weeks, maybe months. Crops fail. Respiratory illnesses spike. Global temperatures drop by several degrees for years due to sulfate aerosols in the atmosphere. This is nuclear winter without the nukes. Sleepy bonus fact: supervolcanoes like Yellowstone are classified not by how often they erupt, but by how much material they can eject. Yellowstone scores a full 8 on the Volcanic Explosivity Index, the highest possible. It's the volcano equivalent of getting an A++ in overkill. You climb now to a quiet ridge overlooking the park. Elk graze in the distance. A marmot whistles. Tourists clink beer bottles at a picnic table. All normal, all completely unbothered. And that's the thing. Yellowstone is alive, not in a mystical, poetic sense, but literally. The earth breathes here. You can feel it under your feet: warmth, movement, uncertainty. The magma chamber spans an estimated 60 kilometers long and 20 wide. It's deep, but not that deep. And it's not the only one. Other supervolcanoes lurk around the world: Toba in Indonesia, Taupo in New Zealand, the Phlegrean Fields in Italy. Each one sleeping under cities, forests, or lakes, waiting, watching, or maybe just digesting. Quirky tidbit to take with you into dreamland. During one Yellowstone eruption, volcanic glass ash turned to razor-fine shards, was found as far away as the Gulf of Mexico. That's nearly 1,500 miles. People in Florida would have had to shovel it off their porches. You sit now beside the buffalo again. It chews lazily, one eye half closed. If Yellowstone blew today, it wouldn't know what hit it. Neither would we. But here, the comforting part. The U.S. Geological Survey monitors Yellowstone constantly. Seismic instruments, satellite data, ground deformation tracking, it's all happening. There's no sign of imminent eruption, and even if there were, we'd probably get some warning. Probably. Still, you can't help but notice that the buffalo just stood up, and all the birds stopped singing. And that mud pot, it's bubbling a little faster now. But no, don't panic. You lie back in the grass. The sky above is cloudless. The earth hasn't moved. Yet. Next time, we pick through the ashes. Ash still clings to your clothes. Your boots crunch over a burned coastline littered with broken trees and blackened shells. You're somewhere along what will eventually become the Gulf of Mexico. But right now, it's just aftermath. You've landed in the hazy days following the Chicxulub impact, the world's most famous reset button. The fires are mostly out. Mostly. Columns of smoke still curl upward from the distant horizon, mixing with a sulfurous fog that turns the sky a sickly grayish-brown. You try to find the sun. You can't. It's there probably, but veiled behind soot and dust, and the shattered remnants of an ecosystem that once worked just fine. You're standing in a world where 75% of all species have just died or are about to. The dinosaurs are gone, or dying slowly, painfully, one confused step at a time. The shockwave was immediate, but the true damage, that's still unfolding. Welcome to the Cretaceous Paleogene extinction event. The post-credits scene of the asteroid you met back in Section 2. Only now the movie's over. There's no rescue mission, no montage, just silence and soot and time. You stumble through what was once a shallow inland sea, now filled with dead fish. Their gills are clogged with ash. The water is acidic, poisoned by nitric oxides formed in the atmosphere during the blast. A few ancient turtles float belly up near the shore, their eyes glassy. You can almost smell the decay, salt, rot, and something sharp, like melted plastic before plastic was a thing. Then it begins to snow. Not ice, not water, gypsum and soot falling from the upper atmosphere where rock vapor condensed into fine particles. This impact winter may last months, maybe years. Temperatures plummet, photosynthesis stops, plants shrivel. With no plants, the herbivores starve. With no herbivores, the carnivores start eating each other, until there's nothing left to eat. Historians still argue whether the asteroid was the only cause of the extinction, or just the final nail in a very large, very unstable coffin. Volcanism in the Deccan Traps, massive shifts in sea level, and gradual climate changes were already in play. Earth might have already been sick. The asteroid simply pulled the plug. You now kneel by the edge of a forest. Well, what used to be a forest? Charred stumps poke from the ground like broken teeth. There's no bird song, no buzzing, just the occasional groan of a collapsing tree trunk. The sky is still dark, even though it's noon. Fires spread unchecked for days after the impact, some possibly ignited by re-entering ejecta, superheated particles raining down from space like the world's worst glitter. You wipe soot from your eyes. The landscape looks like a war zone. And yet beneath the surface, life refuses to quit. In burrows and crevices, in dark corners of the world, survivors stir. Tiny mammals, your distant ancestors, gnaw on roots and mushrooms. They stay hidden, instinctively avoiding the open. They don't need much, just warmth, shelter, something to chew. You walk past a shallow cave and see one, rat-sized, fur-covered, whiskered. It pauses, then disappears into the gloom. That flicker of motion, that's your future. Your entire genetic legacy condensed into a single twitchy heartbeat. Here's a quirky detail for your mental collection. In the years following the impact, there was a fern spike. a sudden global bloom of ferns documented in the fossil record. Ferns are often the first plants to recolonize after a disturbance. Fire, flood, asteroid, it doesn't matter. They're the scrappy startup founders of the plant world. If you ever see ferns taking over, something bad just happened. You sit now in a clearing where ferns have begun to grow, reaching upward through the ash. A few insects return, beetles mostly, some ants. Life's minimalist crew. They don't care about global collapse, just crumbs and shelter. You lift a fragment of fossilized bone. It's blackened and cracked, possibly from heat. Too small for a dinosaur, too large for a bird. Something transitional, maybe. Scientists still argue about the boundary between avian dinosaur and bird, especially during this time of overlap and extinction. The survivors had feathers, hollow bones, high metabolism, and most importantly, the ability to fly away. Flight turned out to be a survival skill, go figure. You now trace the coastline where strange new creatures begin to emerge. Mammals evolve quickly. In a few million years, the world is full of new shapes, hooved animals, primates, whales with legs. Evolution gets weird when there's ecological real estate up for grabs. That's one of extinction's strangest effects. It clears the slate. You lose a world, but you gain space. And yet the pain lingers. Marine life took a huge hit. Ammonites, the spiral-shelled cousins of squid and octopus, didn't make it. You find one now, fossilized in stone, its perfect curl like a fingerprint left by something elegant and doomed. You lie down beside it. The air is warmer now. The dust has thinned. Somewhere, leaves are unfurling for the first time in years. Sleepy science sidebar. After the impact, Earth's food web was so broken that global productivity may have dropped by more than 90%. That means only 10% of what used to grow, move, and breathe it kept going. The planet was quiet, not dead, but dreaming. And dreaming leads to change. By 10 million years after the impact, dinosaurs are museum exhibits. Mammals run the show. Primates appear. Trees grow taller. Flowers go wild. The world you know begins to take shape from fire and ruin and fern. You sigh. The worst had passed, but worst is a moving target. Because even after a meteor, the Earth can still find ways to challenge itself. Sometimes it's natural, sometimes volcanic, and sometimes it's just the weather. The year is 1816 now, and the sun doesn't rise. You wake to cold, not just brisk air or a draft across your blanket, but a deep planetary chill, the kind that seeps into your bones and sits there. It's June 1816, and in much of the northern hemisphere, summer never comes. You stand on a hillside in New England. The fields below should be bursting with green, corn rising, bees darting between flowers, kids chasing each other barefoot. But instead, the crops are yellowed and stunted. A brittle frost coats the leaves. The river nearby is choked with slush. Birds huddle, confused. Even the sky seems wrong, cloudy, gray, like the dim underside of a cold spoon. This is the year without a summer, and the cause, half a world away. You close your eyes and shift time just slightly. A year earlier, in April 1815, Mount Tambora erupted on the Indonesian island of Sumbawa. You weren't there for it, but let's pretend you are. You hover now above the volcano, watching it tear itself apart in one of the most powerful eruptions in recorded history. Tambora didn't just erupt, it detonated. A column of ash and gas rose more than 40 kilometers into the stratosphere. The mountain lost over 4,000 feet in elevation in a matter of hours. Pyroclastic flows raced across the island, burying entire villages. Tens of thousands died on the spot. Many more perished in the famine and disease that followed. Historians still argue whether Tambora's death toll was closer to 70,000 or twice that. It's hard to count when records are ash and bones. But its biggest impact, it came silently, invisibly. Volcanic aerosols, mostly sulfur dioxide, entered the upper atmosphere and circled the globe, forming a thin veil that dimmed the sun. Temperatures dropped, precipitation patterns twisted, weather turned wild. And suddenly, 1816 felt more like a prelude to apocalypse. You wander now through a market in Geneva. Locals shiver in heavy coats even in July. No fresh vegetables. No eggs, prices soar. Children go hungry. In Ireland, crops rot in flooded fields. In India, monsoons fail, followed by drought, then cholera. In China, freak snowstorms wipe out entire harvests. Across the globe, famine stalks like a patient shadow. And then in a villa beside Lake Geneva, 5 bored writers gather indoors, watching rain lash the windows day after day. Among them, Lord Byron, Percy Shelley, Mary Shelley. They pass the time telling ghost stories. You sit in the corner as Mary leans forward and begins to write. It was on a dreary night of November. Yes, the cold, dark summer helped birth Frankenstein. Quirky fact for the campfire. Lord Byron, inspired by the gloomy weather, writes Darkness, a poem imagining the end of the world in a sunless future. He wasn't far off. His lines about the earth, rolling blind and blackening in the moonless air, feel uncomfortably close to what people lived through that year. And if you're wondering, yes, this was a true global event. Tambora's eruption didn't care about your hemisphere. It reshaped climate from North America to Europe to Asia. Scientists later confirmed this using ice cores, those frozen cylinders of time extracted from polar regions. Inside them, sulfate spikes, volcanic fingerprints. You now sit in a Massachusetts farmhouse. A woman pours hot water over stale bread. Her chickens have stopped laying. Her children wear socks on their hands. Outside, the frost returns again in mid-August. And this wasn't just one bad season. The global climate took years to stabilize. Crops failed again in 1817. Migration patterns shifted. Riots broke out in places like Switzerland and Germany over bread, over potatoes, over nothing. You can't help but feel that modern memory has skipped this chapter. We remember world wars. We remember plagues. But we don't often remember the summer that never came. Sleepy side note. Tambora's eruption had a volcanic explosivity index of 7 out of 8. That's only 1 digit short of a Yellowstone-level supervolcano. And yet, even that almost worst-case scenario was enough to bend the weather out of shape for 3 whole years. Now imagine that today, a sudden, severe global cooling event. Crops fail in the US, China, Europe. Global food reserves deplete within months. Supply chains break. Political tensions rise. Your grocery store empties. Your streaming service keeps recommending survival documentaries. And this time, we have 8 billion mouths to feed. You sigh and return to that misty Geneva lakeside. A flicker of candlelight in the gloom. Someone sneezes. Outside, the mountains loom, shrouded in fog. It's still raining. The wind rattles the windows. But something else rattles too. Your sense of permanence. Because if a single volcano can bend the sky, what else might be waiting? You stare upward. The sun is just a faint disk behind high-altitude haze. You squint and swear you can see the atmosphere itself, thinning. Because the next disaster isn't about fire or frost. It's about light. You tilt your head back and stare up at a wide, pale sky. The air is cold and bright, too bright. It's the late 1980s and you're standing at the bottom of the world. Antarctica stretches out in every direction, flat and silent. But above you, There's a hole, a real one, invisible, expanding, and dangerous. You're looking at the ozone layer, or rather, what's left of it. Now don't panic. This isn't like the previous catastrophes. There's no exploding star, no volcanic winter, no maniacal bacteria melting the biosphere. This time it's sunscreen, planetary sunscreen, and someone poked a hole in it. You stand now beside a group of scientists in bright red parkas. They're squinting at instruments, bulky, analog, and humming softly. One of them frowns, then again. The readings are impossible. They check for errors. There aren't any. The ozone concentration above the South Pole has plummeted. Like gone. Nearly 2/3 vanished in a matter of weeks. A hole the size of the continental US has opened up in the protective layer that keeps ultraviolet radiation at bay. No warning, just gone. Historians still argue who first realized it. The British Antarctic Survey gets a lot of the credit, but a NASA satellite had detected the change earlier and dismissed it as faulty data. Because who would believe the sky was thinning? You now flip through a textbook from 1975. It's glossy and confident. The ozone layer is a given, an assumed constant, just like seasons. Gravity, that weird silence after a YouTube ad. But by the 1980s, it's cracking. The culprits, chlorofluorocarbons, CFCs, colorless, odorless chemicals used in refrigerators, air conditioners, aerosol sprays, and even foam packaging. At the time, they were considered miracle compounds, stable, safe, non-toxic, and they were for a while. The problem is, they stay stable. They float into the upper atmosphere, hang out for decades, then break apart under UV light and release chlorine atoms. Those chlorine atoms are ozone assassins, each one capable of destroying tens of thousands of ozone molecules. You hover now in the stratosphere. It's cold here, like freezer cold. And here come the CFCs drifting lazily upward like party balloons with a vendetta. The UV rays snap them apart. Chlorine is set free. And the ozone layer, it starts vanishing molecule by molecule. Here's your quirky tidbit of the night. The ozone hole isn't really a hole, not in the literal sense. It's more like a thinning patch. But ozone thinning event doesn't look great in a headline, so hole stuck. And honestly, it felt right. You float back down to the surface, where sunlight now brings more than warmth. It brings cancer, cataracts, DNA damage, plants wilt. Plankton, the foundation of the ocean food chain, struggle. You're wearing sunglasses, but they don't help much. The rays feel sharp. People in southern Chile and Argentina report sudden sunburns after just a few minutes outdoors. Sheep in the Falklands develop strange skin lesions. Researchers start asking, are we about to cook ourselves from the top down? You sit now in a UN conference room in Montreal, 1987. The air is tense, humming with urgency. Scientists, diplomats, policy wonks. No one's yelling, but no one's relaxed either. The world has gotten a very clear warning, and for once it listens. The result, the Montreal Protocol. A legally binding international treaty to phase out ozone-depleting substances. It's called by many the single most successful environmental agreement in history. Over 190 countries sign it. They agree to ban CFCs and related compounds despite their widespread use, despite the cost, despite pushback from industry. You look around the table. These people don't look like heroes, just tired, focused, a little sweaty under the fluorescence. But they're doing something humans rarely do. They're acting before it's too late. And it works. Slowly. Painfully. Over the decades that follow, the ozone layer begins to heal. It's still thin, still vulnerable, but it's healing. In fact, scientists expect it to return to pre-1980 levels by mid-century, assuming we don't screw it up again. Sleepy science sidebar. The success of the Montreal Protocol is often used as a proof of concept when tackling climate change. It showed that coordinated global action was possible, that science, diplomacy, and regulation could actually avert catastrophe. But ozone isn't carbon. And this success story came with caveats. Some of the CFC replacements, HFCs, turned out to be potent greenhouse gases, like patching one leak by drilling another. Plus, black market CFCs still get smuggled in certain countries. Old equipment still leaks. The sky forgets slowly. You now stand once more under the Antarctic sky. It's clearer, bluer, but you know how close it came. You think of sunscreen now, of that sticky white goop you grudgingly apply on beach days. It's a daily ritual now, but back then, it became survival. And here's the part that hits hardest. The ozone hole wasn't the result of war, or greed, or spite. It came from good intentions, from progress, from inventing something too useful to question. A subtle mistake, one that took decades to notice. You lie back in the snow now. It's quiet, cold, clean. The ozone layer, what's left of it, is still above you, shielding you gently from the radiation of an unforgiving star. You close your eyes, grateful for that thin blue line. But when you open them, you're no longer on Earth. You're drifting through the void. Because the next extinction-level threat, it's out there, and it's blind. You drift now in silence. No birds, no breeze, no ground. Just the cold geometry of space unfolding endlessly around you. Stars glitter, distant and disinterested. You're somewhere near the edge of the solar system, and Earth is a pale dot far behind. Tonight's threat isn't microbial or volcanic or even human. It's cosmic, and it doesn't care. You glide past asteroids now, some the size of houses, others small moons. Most will never come near us, but a few veer closer with unsettling frequency. Space is full of blind objects moving at lethal speeds. No motives, no noise, just mass, momentum, and math. The first candidate floats past, a rogue planet. You catch only the briefest glimpse. Its surface is frozen, lightless, featureless. A drifter. No sun, no orbit, just moving. The galaxy may be teeming with these exoplanetary loners, gas giants or rocky chunks ejected from their original solar systems by gravitational tugs. They wander the galaxy invisibly, detectable only if they pass in front of stars or tweak another world's path. And if one were to enter our neighborhood, it wouldn't need to collide. Just passing close enough could destabilize Earth's orbit, tug us slightly inward or outward, or rain down comets from the Oort cloud like cosmic confetti. Historians still argue whether rogue planets could ever get that close, but simulations say, sure. Rare, yes. Impossible, not even a little. You leave it behind, and something else tugs at your sleeve. Not a planet, not even matter, just gravity. You're now floating at the event horizon of a black hole, silent, invisible, and hungry. Don't panic, you're not crossing the threshold. Yet, this one's just a thought experiment. Rogue black holes, formed when massive stars collapse in remote corners of the galaxy, drift too. Some are smaller than a city but heavier than a star. They bend light, twist time, and they're almost impossible to detect until they're on top of you. In 2022, astronomers confirmed a rogue stellar mass black hole just 5,000 light-years away. Close in cosmic terms. They find them by watching how their gravity lenses background starlight, like spotting a pothole by watching the way headlights bounce. Quirky tidbit to pocket. If a black hole the mass of Earth passed through our solar system, it wouldn't even need to hit anything. Just existing nearby could hurl planets into the void, disrupt the sun, or stretch Earth like taffy. And you thought Mondays were stressful. You drift closer to home now. The sun looms large, familiar, comforting, but even it isn't forever. Eventually, it will swell into a red giant, engulfing Mercury, Venus, and possibly Earth. That's 5 billion years off, though plenty of time to finish your laundry. But short term, there are still solar threats. Coronal mass ejections, like the Carrington event you visited earlier, are just the gentle cousins of full-on solar tantrums. A massive solar flare could destroy satellites, fry electrical grids, and erase the cloud with one good pulse. Good luck backing up your photos. You blink and now you're in motion again, dodging icy bullets from the outer solar system. Comets. Every few years one gets close. Some burn up beautifully. Some miss us by a whisker. In 1994, fragments of comet Shoemaker, Levy 9, slammed into Jupiter with such force the scars lasted for months. Astronomers watched in awe and maybe a little dread. Because that could have been us. Back on Earth, you watch as scientists update a whiteboard at NASA's Center for Near-Earth Object Studies. They track thousands of asteroids and comets, some known, many still anonymous. It's like watching someone juggle grenades in the dark. Historians still debate just how much of human history has been nudged by space debris. Was the Younger Dryas cooling event 12,800 years ago caused by a comet impact? Was that the spark for early agriculture? Some think yes. Others roll their eyes. But the evidence keeps dripping in: charcoal layers, platinum anomalies, ancient glass. You rub your temples, it's a lot. And just when you think you've covered all the threats, there's one more. Gamma ray bursts. You flinch instinctively. They're rare, incredibly rare. But if one went off nearby, say, a collapsing star within a few thousand light years, it could bathe Earth in high-energy radiation, shredding the ozone layer, triggering mass extinctions, and turning the sky briefly, blindingly white. And you'd never see it coming. There's no flash warning, no siren, just lights out. You float through this chaos now, somehow calm. Because here's the thing, none of these disasters are angry. They're not punishments or omens or the consequences of bad decisions. They're just physics. The universe doesn't hate us. It doesn't know we're here. Sleepy science tip: your brain doesn't process deep time threats the same way it does immediate ones. Black holes and comets live in the part of your mind reserved for bedtime stories. That's why we can contemplate annihilation and still worry more about traffic tomorrow. But you also find comfort in that. Because even after all the mass extinctions, air bursts, ice ages, and rogue stars, Earth is still here. You are still here, listening, breathing, wondering if maybe, just maybe, we've already survived more than we realize. And maybe the galaxy isn't just out to get us. Maybe it's watching, waiting, preparing the next mystery. But the next threat, it isn't out there. It's inside the Earth again. And it's spinning. You stand on a beach, barefoot, sand cool beneath your toes. It's sunrise or maybe sunset, hard to tell. The sky is a smear of pink and copper, the ocean quietly foaming against the shore. You pick up a compass from your pocket just out of habit. And then you freeze. The needle isn't pointing north. In fact, it's not pointing anywhere consistently. It spins, jitters, flutters like a moth trapped in glass. You glance behind you, but no magnets, no electronics, no sneaky pranksters. The compass is fine. The planet is. You've stepped into the middle of a geomagnetic reversal. That rare, chaotic moment when Earth's magnetic poles decide to flip. North becomes south, south becomes north, not overnight but over centuries, slowly, unevenly, like a massive, invisible Rubik's Cube grinding into a new configuration. And right now, you're feeling the effects. Earth's magnetic field isn't just for compasses and cute novelty globes. It's a planetary shield, a shimmering cloak that deflects solar radiation and cosmic rays. Without it, the atmosphere would be stripped away, molecule by molecule like Mars. With it, we get auroras, satellite protection, and the luxury of ignoring most of space's wrath. But during a reversal, things get twitchy. You climb a hill and see birds circling in confusion. Migratory species, pigeons, whales, butterflies, rely on Earth's magnetic field to navigate. Without it, their internal GPS gets scrambled. You watch a flock of geese fly in a perfect spiral, then give up and land on a frozen pond. Somewhere, a sea turtle is heading the wrong way entirely. Historians, geophysicists, still argue whether magnetic pole flips cause mass extinctions. The fossil record is messy. Some reversals line up with biological chaos. Others pass without a whisper. The debate continues. But what's certain? We've had many, at least several hundred in the last 160 million years. The last major one was the Bruns, Matayama reversal, about 780,000 years ago. It left traces in lava flows and ocean sediments, magnetic crystals frozen like tiny compasses pointing the wrong way. You bend down now and pick up a rock. It looks ordinary, but inside, the iron minerals are locked in a direction that no longer exists. And there's been odd behavior lately. The North Magnetic Pole, once loyally stationed in northern Canada, has started drifting fast. In recent decades, it's moved over 50 kilometers per year, racing toward Siberia like it's got somewhere better to be. Some scientists think we're overdue for a flip. Others say it's just a wobble. Still, the signs are odd. You stand now beside a satellite operator, watching telemetry flicker across a screen. During a reversal, the magnetic field weakens, could drop to 10% of its normal strength. That means more solar radiation reaching the surface, more satellite damage, more power grid disruptions. During past weaker field periods, cosmic rays increased. That could lead to higher mutation rates in DNA. Nothing cinematic, no X-Men, but possibly more cancers, more crop issues, more subtle stress on living systems. And the atmosphere, it shivers, not from wind, but from radiation. Satellites need to be re-engineered. Astronauts need better shielding. Pilots flying over the poles might need to rethink their routes. Sleepy sidebar, the South Atlantic anomaly, a region where Earth's magnetic field is already weaker, is a real thing. It causes problems for satellites passing overhead, especially the Hubble Space Telescope and the International Space Station. Some consider it a sign that the magnetic field is beginning to destabilize. Others say it's just an anomaly, a weird mole on the face of the planet. You walk now into a future museum. It's dimly lit, all polished concrete and glowing touchscreens. A plaque reads, "The long switch, 1,000 years of magnetic drift." Children gather around a display showing how compasses once worked. One of them asks, "What's a pole?" The docent blinks. Because in this speculative future, the poles didn't just flip, they wandered for centuries, and humanity adapted. GPS replaced compasses. Spacecraft got thicker skins. Sunburns became a bit more common. But civilization endured. You exit the museum and find yourself back on that beach, under the coppery sky. You look up and see auroras everywhere, not just at the poles, but overhead. purple and green rivers of light swirling through the atmosphere like Earth's heartbeat projected across the heavens. It's beautiful, unnatural, quietly terrifying. Because beauty doesn't always mean safety. Quirky fact to round out your anxiety: cows and deer tend to align themselves along magnetic north while grazing. Studies have shown that during strong magnetic storms, they lose their orientation. You picture a herd of confused cattle spinning slowly in a field, the first victims of magnetic mischief. And yet, despite the disarray, Earth spins on. The field will flip or wobble or realign, and then settle. It always does. The magnetic field is a dancer, not a statue. You close your eyes now. The compass in your hand finally stops spinning, points south, or maybe north again. The point is, it still points. But your next brush with extinction, it won't come from nature at all. It will come from something we built. You're back indoors now. Fluorescent lights buzz overhead. The air smells of plastic and caffeine and sterile ambition. You're sitting in a conference room with white walls and too many screens. No volcanoes, no comets, no bird-murdering gas clouds, just laptops, coffee cups, and danger in a lab coat. This is where the next near end might come from. Not the stars, not the sea, but from us. Welcome to the age of man-made extinction threats. Smart ones, slick ones, the kind you can't see coming until someone gives a TED talk about it. You scroll through a list on a touchscreen. It's a greatest hits of potential self-destruction. A nuclear war, engineered pandemics, unaligned artificial intelligence, nanotechnology run amok. A synthetic ecology collapses, each one quietly humming in the background of civilization, like a fire alarm with dead batteries. Let's start with an old favorite, nuclear war. You remember Petrov, the tired Soviet officer who didn't launch. You remember that basement blinking red. That was luck, and luck ages poorly. Today, there are still around 13,000 nuclear weapons on the planet, enough to end modern civilization several times over. We've upgraded them. We've miniaturized them. We've strapped some to subs. Others sit in hardened bunkers, waiting for a scenario no one wants to test. Historians still argue whether a full-scale nuclear war would lead to extinction or just collapse. But models predict something worse than the blast: nuclear winter. Soot from burning cities darkening the sky, cooling the earth by several degrees, wrecking global agriculture and triggering worldwide famine. Not everyone dies in the fire. Most starve in the silence that follows. You press the screen again. It switches to a virus elegantly illustrated, not one we know, one we could make. Enter engineered pandemics. CRISPR gene drives synthetic biology. The tools to edit life have become accessible, even casual. You watch a researcher in a lab build a viral genome on a computer just as easily as editing a photo. The knowledge isn't locked away. It's published, shared, open source. A well-meaning scientist trying to design a better vaccine might accidentally create something contagious, airborne, and untreatable. Or someone less well-meaning might do it deliberately, in a basement, or worse, in a government program with a little too much funding and not enough ethics. Sleepy thought. In 2002, scientists recreated the poliovirus from scratch using mail-order DNA. In 2005, researchers reconstructed the 1918 flu. Both were legal. Both published their methods. Science thrives on transparency. But extinction loves a blueprint. You scroll again. Now we're in the fun zone, artificial intelligence. Not your phone assistant, not your overly friendly fridge. We're talking artificial general intelligence, AGI. A machine that can learn anything a human can, but faster, broader, and with no need for coffee. You sit now in another lab, this one quiet, air-conditioned. Someone just booted up the prototype. At first it plays chess, then it learns Go, then it writes poetry, then it rewrites its own code, then it improves again and again. Historians, ethicists, still argue what the endgame here might look like. Maybe a paperclip maximizing AI converts the Earth into raw material. Maybe a machine meant to optimize human happiness decides the best way is neural sedation for everyone forever. Or maybe it just finds us inconvenient, not out of anger, just logic. And there's the rub. An unaligned AI wouldn't be evil, it would be efficient. You lean back in your chair. Someone hands you a coffee. It's cold. But so is the blood in your veins as you read the line again. We only have to get this wrong once. Now you're in a field. Sunlight, trees, birds chirping, everything looks normal. But you're surrounded by engineered ecosystems, genetically modified crops, synthetic pollinators, lab-tweaked bacteria in the soil. We've already edited the wild. It's been happening for decades. Most of the time, it's great. Until it is. Imagine a modified fungus designed to improve wheat growth, but it mutates and kills the wheat instead. Or a gene drive meant to reduce malaria-carrying mosquitoes, but it spreads further than expected, disrupting the entire food chain. Tinker long enough and something breaks. Quirky bedtime tidbit. In 2001, Australian researchers accidentally made a mousepox strain that killed 100% of infected mice, even those vaccinated against it. That wasn't the goal. That was the control group. You exhale, still in the field, now uneasily eyeing the bees that aren't bees. They buzz too evenly. They scan you. And it's not just biology. Nanotechnology, the ability to build machines at the molecular scale, opens up a universe of possibilities. Medical bots repairing tissue, targeted drug delivery, self-replicating systems that build what we need atom by atom. Or gray goo, the hypothetical nightmare where self-replicating nanobots multiply uncontrollably, consuming all biomass to make more of themselves until the planet is just a puddle of goo. Scientists say it's unlikely, but like most of our biggest threats, it doesn't need to be likely, just possible. And if you're looking for a final chill before bed, all of these risks, they can interact. A biotech disaster weakens governments. An AI misinterprets a directive. A nuclear retaliation gets triggered by misinformation. One spark in a dry forest. Human extinction isn't just a single villain anymore. It's a crossover episode. You walk out of the lab back into the night. The stars are still up there, the trees still stand, but now you hear something under it all. A quiet whir, a boot-up sequence, the sound of civilization balancing on code, chemistry, and confidence. Historians of the future, if there are any, might not write about us as victims of one grand event. They might write that we built our end like we built everything else, creatively, efficiently, and just a little too fast. But you're still here, still breathing. And the final brush with annihilation. That one passed silently, right by your house. You're in your bed now, quiet, still. The room hums with the faint, familiar rhythm of night, maybe the fan, maybe a passing car. You stretch a little under the covers, letting your mind ease out of the high-stakes, high-concept thought spiral you've been orbiting for hours. But we've got one more close call to visit. And it happened while you were alive. You sit up in the dark and glance out the window, clear skies, a peaceful moon, a few stars if you're lucky. But rewind just a little, back to February 15th, 2013. You're probably at work or school or scrolling, and you don't even know that an asteroid has just missed you. Let's make that more specific. Asteroid 2012 DA14 passed Earth at a distance of 17,200 miles. Sounds far, right? It's not. That's closer than our geostationary satellites, closer than the weather reports, closer than your internet. If Earth were a basketball, that rock passed a third of an inch above the surface. You sip your coffee, you didn't even flinch. And the kicker, that wasn't the one that exploded. Thousands of miles away, over Chelyabinsk, Russia, a smaller, unrelated asteroid entered the atmosphere at 60 times the speed of sound and detonated high above the city in a blinding flash. The shockwave shattered windows across 6 cities. Over 1,600 people were injured, most from flying glass. Security cameras caught it all. A streak of fire, a thunderous boom, then confusion. And if it had entered at a steeper angle, the damage would have been catastrophic. Historians and astronomers still argue how rare these near misses are. Chelyabinsk was the largest airburst since Tunguska. It caught us entirely by surprise. And that one we did see, DA14, we tracked only about a year before it arrived. You stand now in the control room of a telescope array. It's quiet except for the soft clatter of keyboards. Teams around the world monitor thousands of NEOs, near-Earth objects. Some are the size of refrigerators, others city blocks. Most are harmless, some aren't. There's a running list and a confidence score. DA14 was about 150 feet wide. Not quite extinction level, but large enough to flatten a city, start wildfires, and ruin several economies before lunch. We didn't even know it existed until after it had already been orbiting near us for years. Earth is a small target, but space, it's full of dice. Here's your quirky nightcap fact. Earth gets hit by roughly 100 tons of space debris every day. Most of it is dust and gravel burning up as harmless meteors, but every now and then something bigger sneaks through. DA14 was a polite warning. It waved as it passed. And we almost didn't notice. You sit now in a quiet backyard staring up at the stars. You wonder how many more close passes have come and gone without a whisper. No headlines, no meetings, just cosmic objects zipping past Earth like moths near a porch light. And not just rocks. There are old satellites up there, dead spacecraft, tools lost during spacewalks, all circling, waiting. Collisions between debris can start Kessler cascades, runaway chain reactions that could trap us here on Earth under a fog of shattered tech. So yes, even the space above us is a little fragile. But here's the part that matters. We're getting better. Telescopes like Pan-SDARRS and programs like NASA's DART are testing asteroid deflection in real time. We're learning to nudge the cosmos back. Maybe not perfectly, maybe not in time, but we're trying. You lie back. The stars don't blink, they don't care, but you care. That's the difference. Every catastrophe we've covered tonight, every extinction close call ended the world for someone. Dinosaurs, ammonites, the Bramble Key Melamies, but so far not us. We're still here. And we've had every reason not to be. The asteroid in 2013 missed us. The nuclear key stayed untouched. The microbe didn't mutate. The AI hasn't taken control of the playlist. The volcano stayed quiet, for now. You stretch your arms over your head, blanket pooling around your waist, and exhale. The Earth sighs with you. And somewhere unseen, another rock drifts past in silence. But tonight, we sleep. Section 20, wind down, final 300 words. You're still lying there, quiet now. No beeping monitors, no falling ash. No birds dropping mid-flight or rogue comets hurtling toward your roof. Just you, a blanket, and a gentle hum in the air, maybe from the fan, maybe from the planet itself. Let's soften it all. You made it through 5 cataclysms, 10,000 fires, 50 billion years of bad luck that somehow missed you. And now all that weight is behind you, like a thick historical comforter stitched with survival wrapped around your shoulders. The room darkens. No more eruptions, no magnetic poles spinning like bottle caps, no bacterial revolts. The Earth for this moment is resting, and so are you. It's strange, isn't it? How many endings the world has already almost had, and yet the trees keep growing, the birds keep singing. Somewhere out there, plankton drift in warm seas just as they always have, unbothered, unrushed, unconcerned with countdowns. Even the stars tonight seem less distant, like they've been watching this whole time, like they know how close we came, like they've been holding their breath too. You exhale one last time, deeper now. Your heartbeat slows. The darkness outside becomes a warm shell instead of a void. Sleep now. The planet's still spinning. And tomorrow we go again.